Hello everyone, welcome back to our channel, and the topic for the day is probability. In our last video, we have seen and understood the concepts related to cards, that is hearts, diamonds, spades or clubs. Now in today's video, we are going to see how to use those concepts while solving any problem related to cards. So without any delay, let's get started directly with the questions. Our first question is, from a well-shuffled deck of 52 cards, one card is drawn. Find the probability that the card drawn will be a face card. Now, first of all, before we actually begin with any question, we should know the formula that we are going to use for solving any question of probability. So here is the formula. PE means probability of any event. It is equal to number of favorable outcomes upon total number of outcomes, right? So we are going to use the same formula here. Let us read the question, and first let me see how many total number of cards I'm having, total number of outcomes. Let me denote it by capital letter T. If you see properly, you are having total of 52 cards. So my total outcomes, the total number of outcomes, they become 52. And what are my favorable outcomes? Let me denote it by capital F here. Favorable outcome means, what do I want in the question? I want my card to be a face card. We know that in a deck of 52 cards, there are 12 face cards in total. So we have favorable number of outcomes also. We have total number of outcomes also. Now we are going to put them together in the formula. So let us write probability. PE means probability of any event. And what is my event here? I want to get a face card. So let me write face here for that. So probability of getting a face card, it is number of favorable outcomes, which are 12 here, upon total number of outcomes, which are 52. Now, very important thing to remember is always convert your fraction to the lowest possible form. So let me cancel this 12 and 52 by the table of 4. 4 threes are 12 and 4 13 times is going to give us 52. That means what is the probability of getting a face card? The probability is 3 by 13. So the two things that you have to remember while writing the final answer is, first thing, it should be in the reduced form. And second thing, that probability of any event, it cannot be greater than 1 and it cannot be less than 0 also. It should lie somewhere between 0 and 1. Right? So this is the answer for the first part. Let me erase this working so that we can concentrate on the second part now. Till the time we'll read what we have to do in the second part, we have to find the probability, but this time we want that my card should not be a face card. So again, if we see, still my total number of cards, they are going to be 52 because I'm talking about the deck of 52 cards. But now, what will be the favorable outcome? That is a question. So, like total number of cards, we have 52. If I don't want a face card, what will I do? I will eliminate from this 52 cards. I am going to eliminate those 12 cards which are face cards. If I'm going to eliminate my face cards, then I'll be left with non-face cards only. So if I subtract 52 minus 12, how much we are going to get? We are going to get 40 here. So what are our favorable outcomes? It is 40. So let us once again very quickly substitute them in the formula. So now probability of event, and here what is your event? Here your event is not a face card. So just put it in the formula. It is going to be 40 by 52. Again, you have to remember, you always have to convert it into the lowest form. So let me reduce it. 4 10 times is going to be 40 and 4 13 times. So what is the answer for not getting a face card? The probability is 10 by 13. Again, we can very well notice that it is in the reduced form, and this value is going to be somewhere between 0 and 1 only. Right? So let's now take up the next question. Here is our second question. From the pack of 52 playing cards, the black face cards are removed And now the cards are reshuffled and one card is drawn at random. Find the probability that it is a black card. Again, we have a formula in front of us that probability of any event, it is equal to the number of favorable outcomes upon total number of outcomes. So as usual, first I will write down my total number of outcomes. See, initially the question is saying from the pack of 52 cards, the black face cards are removed. We know that total face cards are 12, out of which 6 are of red color and 6 are of black color. So if I'm going to remove the black face cards, I will do 52 minus 6. That means for this particular question, what are my total number of outcomes? They are 46 and not 52 because black face cards are being removed. Let us read the question further. Now I will write down what are my favorable number of outcomes. That means what do I want to get? I want to get a black card. We know that total number of black cards are 26. But again, please concentrate on the first line of the question that black face cards are removed. So how many face cards are black? We have 6 black face cards. So if I'm going to remove 6 from 26, my favorable outcomes would be 20 in this case. So I will be left with 20 favorable outcomes. So let us substitute it in the formula. So P, probability of getting what kind of a card? I have to get a black card. So probability of getting a black card, it will be number of favorable outcome, that is going to be 20 here, and total number of outcome, that is going to be 46 here. So let us reduce it by the table of 2 only. So we are going to get 10 by 23. So what is the probability of getting a black card after removing the black face cards? The probability is 10 by 23. Again, you can very well notice that the answer is in the reduced form and the value is going to lie somewhere between 0 and 1 only. Now let us quickly move towards the second part of the question. The second part is we have to get a king. We know that all the 4 suits, clubs, diamonds, hearts and spade, they all have one king each. So again, my total number of outcomes, they will remain 46. But when we talk about the favorable number of outcomes, in all, how many kings do we have? In all, we have 4 kings. But read the question again. The black face cards are removed. That means black colored kings are also removed. So how many kings will be left now? Only 2, because 4 minus 2, it is going to give us 2 only. Only we are left with red kings now. So I'm going to substitute again this thing in the formula. So probability of getting a king, let me write K here. Probability of getting a king will be number of favorable outcomes that we are having 2 and the total number of outcomes that we are having 46. And do not forget to reduce it. 2 ones are 2 and 2 23s are 46. So what is the probability of getting a king? The probability of getting a king is 1 by 23, which is in the reduced form. And also this value is going to be in the range 0 to 1, right? Let us take the next question now. Our third question is, a card is drawn from a well-shuffled pack of 52 cards. Find the probability that the card drawn is 5 of heart or diamond. Once again, before starting the question, let us see the formula that probability of any event, it is equal to number of favorable outcomes upon total number of outcomes. So first, I'm going to denote my total number of outcomes by capital T. And if we read the question, a card is drawn from a well-shuffled pack of 52 cards. So my total number of outcomes, they are 52. Let us see what are my favorable outcomes. We have to get 5 of heart or diamond. 5 is a number card or a digit card. And all the 4 suits, hearts, diamonds, spade and club, they all have 1 5 only. So you have to get the probability that you may either get 5 of heart or of diamond. So overall, how many favorable outcomes do you have? You have two favorable outcomes. Why? One is 5 of heart and in between it is written or. Or you can also have 5 of diamond. So two favorable outcomes are there in all. So let us put them together in the formula. So probability of this particular event, that means 5 of heart or diamond, it is going to be 2 divided by 52. And you can very well cancel it. Do not forget this step, cancellation. 2 and in the denominator you are going to get 26. So the probability for getting 5 of heart or diamond is 1 by 26, which we can very well notice that it is in the reduced form also. And this value is going to be in the range 0 to 1. Now let us concentrate on the second part of the question, and I am not going to erase my total number of outcomes because it will remain the same for all the three cases. So now what is the second part? We have to get a jack or a queen. So now I hope you all remember that jack and queen, they are face cards, right? So how many jacks are there in total? There are total 4 jacks in all the 4 suits. There are 4 jacks in total. And same is true for queens also. So in total, if I have to take jacks, how many jacks we have? 4 jacks. And what about queens? 4 queens also. The total favorable outcomes are going to be 8. 4 plus 4 because again there is or symbol in between. So now if I'm going to put them together in the formula, let us see what we are going to get. That probability of the event, second case, it is going to be 8 by 52. And if we cancel this by the table of 4, we are going to get 2 upon 13. So the probability for the second case, it is going to be 2 by 13. And again, you can very well notice that it is in the reduced form and the value is going to be in the range 0 to 1. Now let us come to the third and the last part for this question. Again, my total number of outcomes, they will remain 52. Now let us see what is our favorable outcome. We have to get ace and king. Read the question very properly. We know that we have 4 ace. We know that we have 4 kings also. But the card should be such that we have to consider both of them together. It is not possible. If you are drawing one card, either it can be ace or it can be king. It cannot be together ace and king. So what are your favorable outcomes? They are 0 in this case because and is written here. You cannot have a card which is ace and king together at the same time. So the favorable outcomes are 0 and you all very well know 0 divided by anything is going to give you 0 only. So what is the probability of getting ace and king together? The probability is 0. Let us now take the next question. Now we have the last question for the day. From a deck of 52 cards, all the face cards are removed and then remaining cards are shuffled. Now one card is drawn at random. Find the probability that the card drawn is 8 of red color. Again, as usual, before proceeding, we have the formula here. PE, probability of any event, it is equal to number of favorable outcomes upon total number of outcomes. So I will be starting my question with the total number of outcomes. So if we see there are 52 cards, so let me write 52, but wait, they are saying that all the face cards are removed. How many face cards do we have in total? We have 12 face cards. So if I'm going to remove them, what will be my total number of outcomes? It is going to be 40. So you have to read the question very, very carefully because if you will make the mistake at this step, your entire question will go wrong. Now let me write what are the favorable number of outcomes. What do we have to find? 8 of red color. Now when it is said red color, hearts are also of red color, diamonds are also of red color. So how many possibilities do you have? You have two possibility. You may either get 8 of diamond or you may get 8 of hearts because red color is there. So we have favorable outcome as 2. Let us quickly substitute them together in the formula. So we will have the probability of this event for getting 8 of red color. What are my favorable outcomes? They are 2. And what are my total outcomes? They are 40. Again, do not ever forget to reduce them in the lowest form. So what we are going to get? Ultimately, the final answer for the first part is going to be 1 by 20. Let us now erase it quickly so that we may proceed with the second part of the question. Again, I'm not going to erase my total number of outcomes, only my favorable outcomes are going to be different. So let us denote it again by letter F. And what do we have to get? I have to get a king of black color. You all should remember that king is a face card, and in the question in the beginning only it was mentioned that all the face cards are removed. If face cards are removed, how can you get a face card of black color, red color? Nothing you will get because the face cards are removed. So what are the favorable outcomes? They are 0. And if you are going to substitute it in the formula, anything divided by 0 is going to give you 0. So ultimately the probability for the second part of getting a king, it is going to be 0 because the face cards are removed. Let us now focus on the third part of the question and see what do we have to calculate. Now we have to get, let me denote my favorable outcome by F again. We have to get a black card. If you remember, how many black cards do we have in total? We have 26 black cards. But we will not forget that all the face cards are removed. And how many face cards are of black color? There are 6 face cards which are of black color. So what are your total number of favorable outcomes? They are now 20. So now if I'm going to put them together in the formula, what we are going to get? See it? It is going to be 20 by 40. Do not ever forget to reduce them. 0 and 0 you can cancel straight away, and 2 by 4 it is going to give us half. So today we have seen the questions which are related to cards. Now hope, I sincerely hope that you are going to practice the questions by your own, and definitely you will be able to solve them also. So thank you once again for watching my video. We'll be meeting in the next session with a new concept. Thank you so much.